Are you setting up your new Voron kit or something similar that's using the Octopus Pro and you want to get CAN bus going to the sb2209 for the stealth burner? Follow along with this video. I'm going to show you how to get all that taken care of. Hey everybody, how's it going? This is Patrick with Stacking Layers. Today's video, I will be showing you how to set up the Bigtreetech Octopus Pro using CAN bus to connect to the sb2209. So this is an EBB board essentially, which is for a stealth burner. So if you're setting up a Voron, of course, you'll know what that is. Or you can even set up something like an Ender, things like that have a stealth burner head also. So this video is not unique to Voron machines. But because most Voron kits nowadays come with this setup, I figured why not help you out and get it done easy. All right, so that's what it is. What we're going to be using. We have the Bigtreetech Pi. That's the Raspberry Pi alternative by Bigtreetech. A lot of kits are coming with this because of the fact that it's a good, affordable board to have in there. And then you have your Octopus Pro. One thing about this specific one, this is the version 1. This is an older version. So this is a version 1. There is a version 1, version 1.0 is what this one is. There's a version 1.01. Between this board and that board, there's virtually no changes. A couple tiny little component changes, but nothing big. But then there is also what you may be getting is a 1.1. The 1.1 has a different connector on it. So this one uses this RJ12, RJ11 connector, which is kind of like a DSL connector. Works fine, but the newer version, the 1.1, which I'll flip over to the screen and show you now, that 1.1 comes with the standard JST connection. It's the HX, if I remember correctly, HX 2.5 or something like that. This is the most commonly used plugin that comes with these boards. And as a matter of fact, when you get the EBB, it comes with the whole CAN bus line, and they've already crimped on that connector for you. So obviously here, there's a little extra that needs to be done because we can't plug that in there. But with the newer 1.1 board, it's going to click right into that pin. All right, so that's the biggest difference. Everything else about setting these things up are going to be virtually the same thing. I'll point out a little tiny differences here and there when it's needed. Okay, it's all untangled. So I've already gone and plugged things in when it comes to power, just to kind of save you watching all that stuff. But to give a quick summary of what's going on here, what I've done is into the board, all I have is power from the power supply. So you have your plus and minus on here, and that's what's going in here. And I have power from the same power supply going over here to the to the Bigtreetech Pi. The really nice thing that's different from the Raspberry Pis is this has a built-in power converter in there. So it's taking the 24 volts and dropping it down to the 5 volts and 3.3 volts that the system in here needs. You can alternatively power it via USB if you wanted to. You will need to use the little red jumpers that come with it, or I think they're red. Mine is. And you need to jump that cable, those two little pins there. This is only if your power supply is coming only from the USB power input. So if you have like a standard plug that you're using or something like that, do not have this jumper on with USB plugged in and power here. Don't power from two sources at once. So if you have your 24 volts, unplug that, okay? That's a safety thing. You don't want to blow out your components. One other thing with the power, I have these two thin lines. Now this is just for this video demonstration. These aren't the recommended lines to be using for these. You do want to get something that is just as thick as lines are here, the power lines, if not slightly thicker, just to support any type of current that's going through those. All right, for right now, I'm not going to be powering up any heaters or anything on here, so these are sufficient. But just so you don't follow my example with the thin wires, get something similar. So you want to get like 0.75 or 1 millimeter wires per metric. I think it's like something around the lines of 18 AWG, so 18 gauge wires. I think you probably get away with maybe 16 gauge also for these powers. There's not a huge amount of current going through them, but I wouldn't recommend anything lower than that. Okay. So what do we got here with this wire mess? We have the the sb2209 cable. That's the other end that gets plugged on to there, this connector here, right? That's supplying both power on the big wires, and then the two little ones are the CAN bus. This kit is, if you get, for instance, I'm mainly pointing this one out because of the fact that I got the SIBOOR, what is it called? The Voron 2.4, and it came with this connector. So I'm assuming it's going to come with this board with the older style plugin. Makes sense because they're affordable still, and it's perfectly good. But because of that weird plugin, they provided you with this, which is really nice. And so that will get plugged into here. And this is for your CAN bus only. This is only for the CAN bus signal. That goes there, and then that plugs in like so. All right, so you get your power on those two cables and then your CAN bus. Pretty simple, right? On these wires, yellow is high, green is low. And I point that out because if we come back over here, if you look down into this corner here, I don't think I can move that over. But you see it says CAN H and CAN L. So you want to make sure that the top pin on this one is the low, which that will the green cable. If you're going to be making your own connections, your own plugs in for here, the top pin is the green and the bottom pin is the yellow. Okay, just to point that out. So let's get back over to here. So that's the wiring. Pretty straightforward. Not really much to do. The original line, let's pull these out actually. The original line that comes with the sb2209, the big CAN bus line that you get, when you get it, it'll be pretty much, it'll be like with the heat shrink wrap and all that good stuff, right up to where you just have a tiny bit amount of wire sticking out, and it'll also have some solder on the tips. As you can see here, I have removed the solder and stripped back some new insulation. So I got bare wire. If you're going to put any of these type of power cables into clamps, where you're going to be clamping down and putting any pressure on it, you want to get rid of that solder. Solder is good if you're going to be actually soldering to a pad somewhere, then you can use solder, no problem. But anytime solder is put under pressure, it will actually cause cracks, micro cracks, and which create heat, which in turn cause a thermal runaway that is not detectable. It'll cause the solder to creep away from the areas because it's not going to make it molten or liquid, but it will soften it up enough that it can flow out slightly over time. And what that does is it creates a loose connection inside the terminals, which basically creates a lot of heat. I'm sure if you follow the community, you will notice occasionally, for me, I notice it almost on a weekly basis, definitely every month I see it, where you have people complaining about their melted terminals. They smelt burning. They looked at the machine and they found that it was melted, and they start complaining about cheap this, and everything's bad. What's going on is because they did not strip back the solder, or they had a very loose connection. They didn't torque it down enough. And doing that will cause a lot of excessive heat here. It's not that the fuses can't blow or that they use the wrong ones or anything like that, but that it's actually not drawing enough current through these to blow the fuses. So of course it's not going to do it. And there's no way for the system, the logical system, to know that there's too much heat on there unless you have gone and designed it and put a physical heat sensor on there and use that. So when you see burnt terminals, that is 99% of the time because of a bad connection. Also, as you can see, I have stripped a little bit more because I like to have more wire, which you may need to do too, because you may need to get to your power supply there and your other connection here, which obviously is not long enough. So when you're stripping that back, I mean, again, this is just some tips. I'm sure you guys know how to strip wire, but because there's some thin, fragile wires inside here, use an X-Acto knife or some sort of hobby knife to do the insulation. Where did I throw mine? Here, I got some old insulation here. So all I do is put a little bit of pressure. Don't press down on it. Just put a little bit of pressure, just enough to get that blade to bite, and then just slightly turn the wire. More or less what you want to do is just to mark it, to score just the top layer. You're not wanting to cut through. If you notice, the reason why I'm explaining this, if you notice where the wires are, some areas are a lot thinner than others, right? So you have this down here. It's got a really thin, very close to the wire, but then you have this other area that's thick. So you just want to score it just enough to start getting into there like that, where you're not actually cutting all the way through. And then you bend it. And when you bend it, when the wires are inside there, it'll actually, you can see it's kind of doing it there. It'll start tearing the next layer out. And that bending motion will allow you to start pulling away. So you can just bend it back and forth a little bit, and you'll see that the insulation kind of tears itself. And then you can go through and slowly slice and get things cut. So just be careful about that, of course. I mean, all right, another thing with these power cables is it's actually recommended to have the positive side with an inline fuse. Personally, I like to use an actual separate fuse, so it'll have like a fuse holder that I can change out the fuse if need be. But then you can also use the onboard fuse here. So the bed, if you're using like a Voron system, most of them are now AC beds. So you're using mains voltage. So you're not using these terminals to control your beds. You can just use one of these to control the signal. So it gives you a nice built-in fuse to utilize. And the way to do that would be to come in with power from your power supply to the standard power input. Then using the similar thicker wires, loop from minus over to minus and plus to plus. And as you can see underneath the board, it does say which ones they are. So you'll loop from here to here and then there to there, of course. All right. And this is your bed input. And this is basically just supplying power to your bed system. All right. And so this is the power in and that's the power out. Then what you would do is plug just on the plus, not the minus side, the plus on the bed out for your sb2209, and then the minus along with the power. Because the minus is just a return point. But the reason why you plug in the plus on this side, because in between these two positive connections, so the input and the output, lays this fuse. So that gives you an onboard fuse to utilize. And that's just one tip. Currently, I'm not going to do that. As you can see, I have it plugged in directly to the same power source. I'm not going to be powering anything except for the chip itself, so it's not that big of a deal. But when it comes to drawing current, you're going to want to have a fuse in line. It's for safety. Why not do it, right? So that's one easy way that you don't have to buy extra components. You can utilize the system. So I'll just use this for demonstration. You would have a little short wire like that going from minus to minus and then from plus to plus. And then the last plus for your SB will be right there. Hopefully that makes sense. If you have any questions, of course, leave them down in the comments and I will definitely help you out with that. But for now, I'm using WAGO connectors. They're just these simple things to make it easy. If you decide to use something like this, just make sure that you take off enough insulation here to go in and not pinch insulation. So it's an 11 millimeter depth that they recommend. This is not 11 millimeters, so I'm going against the rules, but you can also see inside. So as long as you can see over here that there's a tiny amount of wire still exposed, you're not pinching insulation, because again, pinching insulation will cause overheating problems too. So get in there, give it a light tug on there, and you can see they're well connected. So let's get those plugged in. And right now I'm just plugging these in just to have it ready to go, but we're not going to be powering up the EBB just yet. All right, so we're good. So that's the wiring. We got power to there. Oh, I of course forgot an important thing. We need to be able to connect to here. That's just going to be a simple USB-C that comes with the board. So plug in there, and that goes over here to USB-C. That's it. Simple as that. Okay, so this is a dirty example, but this is how your board gets connected. You have power coming to your board, and then you also have power going out to the EBB via the canbus line. You have your green and yellow, which are the canbus lines, going into either the RJ11 plug or into the one I showed you, the one that will just plug straight in, the JST plug. And then, of course, power here and USB. Done. Simple, right? So let's move on to doing the fun part. Let's get this thing programmed. We need to program the Octopus to be a USB to CAN bus bridge. That's nicely built in. And then but before we get into that, I want to give a huge thank you to PCBWAY, our channel sponsor. And here's a short video about that. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBWAY. PCBWAY isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machine parts through CNC machining and so much more, PCBWAY has got you covered. A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBWAY takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBWAY offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBWAY services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBWAY for sponsoring this video, and now let's get back to the video. Alrighty, welcome back. Let's get this thing programmed. So, first thing, I'm going under the assumption that you already have your Raspberry Pi, or this in case, the Bigtreetech Pi, set up with Klipper. You've installed your operating system, all that good stuff, because you've come so long that you're doing the main board and adding canbus. Hopefully, you're able to get that done. If you need help, I do have another video that was an older video of how to set up some canbus stuff that goes over some of that. But I also, there's plenty of videos on how to do the installation. If you're using the Bigtreetech Pi, it's as simple as just burning the SD card and putting it in, because it has Klipper and everything already installed, which is really nice. But get your Klipper system set up and then move on to this point here. Now, on the Octopus board, there is a little jumper right underneath here. And I've already installed the actual little jumper, but this is your boot jumper. On newer boards, they'll have a button. So actually, I can show you here on the EBB, which we'll use later. Sorry, the sb2209. It has these buttons. So you have a boot button and a reset button. And those are how you would get into what they call DFU mode or into boot mode. With the Octopus board, it's that little jumper hidden right next to this red rail here and next to the EXP thing. Two little pins that you use a jumper on. All right, so that's in place. And the reason why you want that in place is because this is going to allow the board to talk to your host computer. So I'm going to be referring this to the host because it could be your Raspberry Pi, it could be your Bigtreetech Pi or some other system. As long as it's a Linux system, you're good. Anyways, that puts this board into, because it's an STM chip, it puts it into boot mode. And so this is allowing the board to program or send actual firmware into the chip here. Okay, so make sure you have that boot there and you're plugged in the USB, and then you power up. And that, or you can just plug it in. As long as that boot's in there, when you plug in, you're in DFU mode. Okay, so here we are in PuTTY. This is what I like to use. You don't have to use PuTTY. There's several other ways to get into these host computers. PuTTY is one of my favorites just because I can save configurations and whatnot. But we're going to be doing the SSH. If you don't know what PuTTY is, there are plenty of videos out there about that, but all you need to do is, I'll put the link in the description, just download the PuTTY program, install, open it up, and you'll be greeted with this screen. So we'll show you next what goes on here. Like I said, I like using it because we can save. So I'll just load it up so you can see what it is here. So you power up your Raspberry Pi, get it all hooked up to your internet and all that good stuff, and then you'll get its IP address and put it in here. And that's pretty much all you need to do. And when you have your IP address in there, you leave this on 22, leave it on SSH, you hit open, and that'll connect to your device. As long as your IP address is correct and you're connectable, then it'll pop up to here where you have a login or whatever that specific device has. This is Bigtreetech style, so you'll log in, and for Bigtreetech's Pi system, it is BQ for user, BIQU, hit enter, and BIQU again for password. When you type in passwords, it looks like nothing's happening. That is normal. Just know that it is typing in the background. Hit enter, and you're in. All right. So this is unique to the Bigtreetech stuff. This is the Bigtreetech Pi, but if you have a CB1, it's going to look identical. It's the exact same hardware and whatnot, all the chips and everything the same image program and all that good stuff. So you're in. If you have a Raspberry Pi, this obviously will look a little bit different, but same idea. Log in, and you're good to go. So if you want to check that you got things in here, you hit LS. That's going to be list. And this is showing us what we have. As you can see, I have a lot of different things, so yours may look different. Keep in mind, it's not going to look identical to mine, but you want to make sure that you have Klipper installed, your Klippy environment, and then whatever else you need for Klipper to run. You should be having Klipper running already as your main system. All right. So first thing first, what we're going to do is to set up that Octopus board. The way we do that, I set up firmware. for the Octopus board. So what we do, we want to cd, that's change directory, into the Klipper directory for, oops, get into there. Now we're in the Klipper directory. As you can see here, it says that we're in Klipper. And then the command to make firmware is make, and then menu config. Let's move this giant cursor out of the way. I made these big so you guys can see. Menu config. All right, hit enter. And this is going to bring you to the Klipper firmware configuration. So this is where we tell Klipper, or we set up our Klipper firmware. We tell it what kind of board we have and all that good stuff. There's a chance that it looks like this if it's the very first time that you open it up. And so it's a very limited thing. So the way to navigate here, we use the up and down arrows. We cannot use the mouse to do this. So we use the up and down arrows to go to the line, and then we use, out of my way, then we use the arrows to select, or you can use spacebar to select and deselect. All right, you want to make sure that that little star is there saying enable low level. Then we get into our microcontroller architecture. This is where we're going to choose what kind of chip system that we're using. Stuff on my desk here. All right, and we are using on the Octopus board, it is an STM chip, STM32 chip. All right, so we go into there. Then the important part is we need to also come here to the processor module, module, and select which one that we have. As you can see, there's a lot of different ones. You got the arrows down. Oops, what did I do there? That's not right. Let's go back. There we go. As you can see down below here, there's lots of arrows. That means more. But let's go back to our board because it's something important. If you notice here on the board, or I should say if you notice, but if you look at the board, this is the main chip. This is the chip that we're looking for right now, what we're contacting. And I know it's upside down, but I got the wires. I'm not going to twist it around. But as you can see, there's these numbers here. It's the STM32, and then we got these F446 and then ZET. That F446 is what we're going to be looking for, because the Octopus boards comes with, I think, available 3 different variants of chips. It was, depending on which model or year that you got them in, there's different chips available. And it is important to know that because there's different ways to program these things. So since we got that, why did that go away? That's interesting, it stopped. Okay, let's go back there. Make menu config. Okay. Here and there. So now we look for that. The F, let's see, where is it? 446, right? Look at that, right? Double check. Yes, F446. All right, that's the one we need to select for this one. Now, of course, your board may vary. Make sure that you have the correct numbers. Whatever the F and the 3 numbers after is, that's what you need to make sure you are. And then the next step is going to be set up your bootloader offset. Again, this is dependent on which chip you have in here. On this one, actually, I will show you one way to figure that out, obviously looking at the board, but then the next ones is your offsets and your clock reference. Let's see, if you come over to the Klipper page here, this is the Klipper configurations for this specific board, generic Bigtreetech Octopus board, right? The version 1, version 1.0 and 1.01 are the same. As you can see here, there may be several different chips. So this one has 3 different chips. And when you're using those 3 different chips, depending on which one you have to set different offsets. So if you're using the one that I have, which is the 446 board, then I need to set a 32 kilobyte bootloader and use the 12 megahertz crystal clock reference. If you're using the other boards, this one is the 429. It also has a 32 kilobyte bootloader, but it uses the 8 megahertz crystal. And if you're using the one with the 723, it uses a 128 kilobyte bootloader and the 25 megahertz crystal. So that's why it's important to check. All right. And what's really nice is normally when you have these configuration examples, I will of course put this in the description so it's easy to get to. is they normally have this at the top, what you should be setting for those make menu config. Thanks for your microcontrollers. All right, let's get back over to PuTTY. So as you can see here, it says 8. That's the wrong one. We need to use 12 on this specific board for the 446. Now we're good there. And now we need to set up the communication interface. And this one, we're not using USB. What we're using is USB to CAN bridge. This is allowing the USB signal to be converted to a CAN bus signal. Next, we need to set up the actual pins. The ones that are defaulted are not correct on this board. For this one specific, it is PD0 and PD1. As far as I recall, it is also the same on the version 1.1. So both of them should be that PD0, PD1. All right. The next step, you want to come to here and make sure that this number is whatever you set up your full system on. So basically, I recommend leaving it at this number here. This is the 1 megabit CAN bus speed. You can use 500,000, but if you're going to be using, for example, the accelerometers, they need a fast enough speed in order to give a clean signal. So just leave it at that. It's recommended now by Klipper to leave it at that thing. All right. So that is all we need to do for this setup. You hit Q for quit, and this is going to ask you if you want to save. Of course you do. And then it comes out to here. Now to make it, all we did was set it up. Now we actually make it. And to make it, you type in simple as that, make, and hit enter. And now it's going to go through and actually make the firmware for this board, for the Octopus. This can take a minute, so I'll fast forward. Okay, so now that we're back out here, we're able to flash the system. So first, I want to make sure that my board is connected, and the way to do that is you hit ls USB. And this is going to be list the connected USBs, things that are connected, basically. Hit enter, and then if you see this here, then you know that your board is connected properly in DFU mode. This is the download firmware update mode, basically. And so the important thing that we need on this, that's a good thing, it's connected correctly, but we need this here, this number. That number is going to be our ID that we're going to be using for this next command. Really nice and easy. As long as you have it in DFU mode, we can use a command that is make and flash. And so this is telling the make program to flash, and then we use all capitals of flash and then underscore device. And then equals, and then this number here. Now with PuTTY, when you're using PuTTY, if you highlight something, it automatically copies, and you just right click and it puts it right down wherever the cursor is. Really nice, quick feature. So you can copy whatever you want and just hit the right click on the mouse and it'll copy it in. So this is the command that we use to flash that device with the firmware that was just made. Now we're in the Klipper system already, the Klipper directory, so it knows you don't have to put the file of where it's located because it already knows. So we'll just do that and hit enter. Hopefully, if everything is connected properly and talking, it should flash over. There it is, doing its thing. And then we're good. Now we're good. Now you may notice right here, it says DFU utility error during download status. Ignore that. What we're looking for is right here, file downloaded successfully. So what happens with these specific chips, when it gets a firmware, it automatically reboots itself with that firmware. And so it fails to reconnect immediately or connect fast enough in order for the DFU utility to check. Because what it does normally will go and check to see if the flash flashed. And so it's saying that there's problems and it's saying, yeah, well, if you try these, blah, blah, blah. Don't worry about all this. This whole line right here, all of this warnings and whatnot is irrelevant for the system. Okay. As long as you see this part here, downloaded successfully, it worked. Okay. And that is it for that one. Don't worry about those errors. I know it's kind of sad. I wish they would fix that or figure out a way to make it so it doesn't happen. Or if I find a way, I will definitely put a note somewhere and show everybody. But don't worry, it worked. Okay, clear the screen out and let's move on. And before we go too far, we need to remove this little jumper because we don't need it to be in boot mode anymore. Power down your board. It's not good to be removing things. I don't actually believe that's going to cause an issue with this specific one, but it's not a good idea to be removing things when things are powered up. Okay, so go ahead and get rid of that, but first power down. Okay, so we'll be right back. I'll do that. Okay, so jumper's gone, powered back up, and we're back in putty. Okay, so now before we connect for CAN bus, we need to check that things are set up for CAN bus to communicate. And to do that, it's actually documented in the Klipper CAN bus. So I will point that out. And of course, always put a link in. So let's see, let's move over to this screen. And this is the Klipper CAN bus, Klipper documentation in the CAN bus section. Again, like I said, I'll put a link to that. And what we need to do is make sure that we have CAN 0 set up. So that is in this section here. So if you copy that line, this whole thing, make sure that you have all of those little forward slashes all the way to CAN 0. So copy that in and then come over to your putty or wherever you have SSH in and paste that in. But in front of that, we want to do nano, sudo, S-U-D-O-N-A-N-O. And what this is, you have to make sure space, so sudo space, and then nano space, and then that will be copied. This is giving us super user, or it's giving us root ability, so we can write a new file. Nano is a text editor that's built into Linux, or it's in Linux systems. And we're going to be writing a CAN 0 file in these directories. Okay, that's what all this is. So it's the etc directory. Inside there is called network. Inside network is interfaces.d. And inside interfaces.d is where you set up things like CAN bus or other types of communication systems or interfaces. So a different Ethernet port or stuff like that. But we're setting up CAN 0 is what we're going to be using. So go ahead and set it like that. Hit enter. And you should technically already see something like this. If not, if it's a blank screen, it'll be a new file. That's fine. That doesn't mean anything's wrong. But what you need to do is go ahead and paste all that in there. I will have this in my description, or if you were on the Klipper, on the Klipper thing, it's down here. One difference though, I recommend not using such a low transmit queue length. These numbers here. 128, I mean, most time it should work, but if there's something that you get into more advanced stuff and it's sending a lot of data at once, that's going to be too small. So I recommend using, okay, like you see here, I have 1024. So that's what I recommend to use. The only time that a smaller number is really needed is if you're having a lot of CAN bus noise issues, problems with your line. You can drop down to a lower speed. I'm sorry, a lower transmit queue. What this is the amount of megabits or amount of bits that it can send out at one time. So it's packages of information. So if you have a smaller number, there's tinier packages, so there's less chance of things getting lost in translation. So if you have a very noisy area, a lot of electrical interference, a smaller number can help. But a smaller number can also cause not enough data to be sent for things to run. Okay? Hope that's not confusing. Set it up like this. I've never once had an issue with that. I set up all my machines like this and it works. Okay, so make sure that that's there. If you had to copy and paste and put that in there, then you would get a notice to save. So right here, you got this down below, it says exit, right? You use that little uptick called the caret. That means hold control and then X. Control X is the exit. But let's see if it does it. Yeah, it's not going to ask me. So let me do something. I will edit it so you can see what it looks like when I edit. Let's just put a space. So when you exit, when you actually paste it in, you'll get this one. It says the save modified buffer. Might be a little intimidating if you're not knowing what that is. Basically, it just means, do you want to save it? So you would hit yes, right? And then when you hit yes, it again comes to this menu, says file name to write. And it's going to be CAN 0. Yes, that's what you want to write. You just hit enter. All right, and then you're out. I'm going to go ahead and change that back because sometimes spacing is important. So if you notice, I have these two lines. This is on its own line. This next one is on its own line, and so forth. But this has an indent also for these two lines. So make sure that it's set up like this. Each one on its own line, and these two have indents. I can't remember if these two indents are extremely important, but I've always done it that way, and it's always shown that way, so it could be. Sometimes if you don't have indents, it won't read it properly. So just make sure that those things are there. If you're having issues, come and check and see if things are like set up like this. All right, so that's enough of that. Let's save that, get it out of there. Now that we have that set up, we should be able to have a CAN bus communication, and you can actually check various ways with that. If you have, for the first time, made this file, that file was blank when you first opened it, you do need to reboot now. So just type in reboot and hit enter, and it'll reboot your system. Because if you don't reboot, it's not actually going to turn on the CAN bus until you do reboot. Okay? So once you're rebooted and back in, then come back and get into Klipper folder again, Klipper directory. So I will not hit reboot, but I will do CD. So when you come back in, let's just clear. Control L clears out. It's not removing anything, but it just brings up the top line. Gives you a clean slate. So when you log back in, you're into your home directory. You want to CD Klipper again and get into there. And now we're back into Klipper because now we can query for the CAN bus. So to query, we actually have to use scripts that are built in. And if you come back over to the CAN bus guide, it does actually tell you the script to use. I like referencing these things because, as you can see, it's a long script, long path that you have to clip in. So just easily copy. But what this is saying is go into the Klippy environment directory and then the Python setup. So it's a Python environment. And then using that Python environment, I want you to run this script, this Python script, and check for CAN0. So it's a lot going on there. That's why I recommend having these pages bookmarks so it's easy just to copy. You don't have to remember all that stuff and type it in. Plus, if you just copy this out here, there's no typing errors, because if you don't have the right symbols, like these little tildes, as they're called, and spaces in the right spots, it won't work. You'll just get an error. So you come back to Putty, right click to paste that in, and hit enter. Hopefully everything goes right, and you will get this, found canbus UUID, and you get this number. All right, being that we have not plugged in our EBB board, or sorry, their sb2209 board yet, done anything with that, this UUID is the UUID for the Octopus. It is vital that you save this number. Put it onto a notepad or something. Make sure you get just the number. And with Putty, if you hold Control, Shift, and C, you can copy out. All right, so I'm going to go ahead and put this on a notepad off of the screen here so I don't lose that. And before we do anything with Klipper, do not go and put this number into Klipper yet. Don't check it yet. You have it. That's good. Now we need to move on and install the firmware for CAN bus to the sb2209. So now we're going to be programming the sb2209. And I'm going to be adding an extra step. It's virtually the same thing that we did to this board, but I'm going to be adding the extra step of installing Katapult. Katapult, formerly known as CanBoot, is a really nice setup because it's a bootloader that gets installed, which allows future upgrades of firmware to be done over CAN bus or USB, whatever you're connected to. But it allows you to do the CAN bus update without having to press any more buttons or anything like that. This step can be skipped. You can go directly and install only the Klipper firmware, which is fine. It'll work. The only downside of that is that you will have to come and install, if you need to update your board, the firmware on there, you do need to come back in and put it back into boot mode to install things. So if you have Katapult installed, you no longer need to do that. So that's why I recommend it. If you don't want to do it, if you feel it's a little bit too complicated or a little bit too much to get involved with, you don't need to do that. Okay, but that's what we're going to do now. So let's get this set up. So we get the USB. We do need to have this back in the board because, like I said, this one is set up as USB to CAN bus. But right now we're going to be using this to install the Katapult. So go ahead and plug that in. Actually, first what we need to do, you see these two little jumpers there? We need to jump these in order to get power from the USB. I'm not going to be powering it from the CAN bus just yet, just because I have everything plugged in, but it's enough power just for setting up this way. Okay, so let's get the little jumper. It should be in the bag here. And it is a tiny little guy there. Yeah, they're in there. So be careful with these because you don't want to lose those. These are probably the smallest jumpers I've ever seen. As you can see there, it's that tiny, tiny little guy. So let's get that and put that on. It's these two pins right there. Can you see them next to the capacitor there? It's labeled USB 5B. So you put that jumper there. There you go. So once that jumper board is on there, it's going to take the USB power to power the chip. All right. Then you can plug it in. And you should see you got a little light stating that there's power. And then before we go and program things, what you have to do is hold down the boot button. The boot button is this one here in this orientation. It's the left button. That's boot. And then click the reset. So hold this one and keep holding it. And then click that button. I'm going to use a screwdriver. I don't recommend this, but because my fat fingers are in the way so you can't see, so you go and click it, and then you can let go of boot. All right. So the sequence is hold down boot, keep holding it, and then click reset, and then let go of boot after. And that's going to put this into DFU mode. It's boot mode because it's a Raspberry Pi. They call it boot mode. All right. So set this aside, set in a safe spot. Don't short out. Remember, there's exposed pins underneath. Don't short it out on anything. Okay. Then we come back to our putty, and you can again run ls USB to query, and you can see now it's showing the Raspberry Pi in boot. And it's got a different number here. So this is what we're going to be using. But before we do this, we need to download the Katapult software to get this installed. And to do that, we come over to ArcSigns here. This is ArcSigns repository. This is Katapult. Again, I will have the the link in the description. But if you want to do it your own, ArcSign at GitHub and then Katapult repository. And what we need to do first is to install or to download the repository. This first command line here is going to download all of this to your system so you can use it. So it's just that you can clip the copy here, but if you use copy, it's going to copy all of these lines and run them when you put them in. It'll do them all at once. So you don't want to do that. It may work. Sometimes it doesn't though. So I recommend doing it line for line. All right. So let's get that first one copied. Okay. So we come back to putty, and as you can see, we're still in our Klipper directory. So you do not want to be in that. You want to be in your home directory. So go ahead and hit CD and enter. And that brings you back to your home directory. That's symbol of the tilde plus the money sign means you're in your home directory. And then we paste in that link for the Katapult and hit enter. And this was going to clone, download all that to our system. It's relatively small, so it doesn't take very long. Now we need to go in and make the firmware. So to do that, we first go into Katapult. So we can check it if it did actually go in there. As you can see, Katapult is here now. So you do CD in Katapult. Move this giant cursor out of the way. And hit enter, and that brings us into there. Now for Katapult, it's the same setup as the Klipper for make. We do make and menu config. Make menu config, enter, and it's going to pull up our system. So as you can see, it's very similar to the Klipper setup, except for now it says Katapult configuration at the top, right? So we need to get our board set up. So the first one is not an LPC. We are using on the sb2209, the one that I have is the RP2040. There are some that are the STM32s, so make sure to check which chip you have. This one is the RP2040. And so with the RP2040, this part here stays the same. And we want to have the bootloader for the Katapult deployments application. So this allows us to do the flashing of everything. USB communication is not what we're doing. You can do USB if you want. The downside to using USB on these boards is that you still have to provide power separately because you cannot provide enough power through USB to power up your hot end and motors and all that stuff, of course. So That's why we're doing CAN bus, separate power source. We've got CAN bus set up in there, and these two you leave the same. They're 4 and 5. That's good. If for some reason you have a board that's a different number, then you would go in and change that number, but we're not. And then the 1 megabit or the 1000 CAN speed, that is important. Leave it the way it is. Make sure that all of them are the same. If you changed it in one of the previous steps to 500,000, for instance, you do need to change it here too. Everything needs to match, otherwise they will not communicate to each other. Okay, the rest you can leave the same. So it's pretty painless, right? Hit Q for quit, and then yes to save what we just did. And then the simple command of make, M-A-K-E, and enter. And this is going to create the files that we need. I'll fast forward. Okay, so that's all done. Now, of course, we want to make sure our board is in boot mode. So double check that, ls USB. And as you can see, it is in boot mode. If it's not there, then we want to make sure to get into boot mode. Again, with it plugged in, all plugged in, you press and hold boot and click on the reset button, then let go of boot. Simple as that. Run the command again and you should see it. If for some reason you're not, you would need to try again, check your power, make sure your USB cable is good. Try a different USB cable. Sometimes they are bad or not USB communication, they're actually just power. That can be something that happens too. If you're not getting this boot, try a different USB cable. Anyways, back to putty. So now we need to flash it. And it is as simple as the previous command was of make. You're saying, calling the make program, saying, hey, make, I want you to flash. Space, get this cursor out of the way. Make flash, and then all caps. All caps is important on this part. The flash device, underscore device. And then equals. And then we want that ID there. So highlight it. Make sure there's no spaces highlighted in front or back. And then right click, and it populates it down there. Hit enter. And it will go through and really quickly do its thing. So if you see it all set up like this, where it says that it's exiting, erasing, flashing, reboot, you're good to go. It did its thing. No errors or anything like that. Okay. Now we need to make sure everything is plugged in correctly. Of course, I already have my CAN bus plugged in and my power on here. We no longer need the USB plugged into the board here because it's now programmed. We're not going to be using USB communication anymore. So you can actually put this back into the Octopus board. Okay, so now we have the Octopus communicating through here. And with this board, the one that uses this connector, something I need to point out, the one that uses this connector has a built-in 120 resistance, what they call a termination resistor. So you don't need to worry about that on this specific board. But let's go over, let's see, where is this? Go over to these boards here. Not that one, but the 1.1. Yeah. There we go. But on the 1.1 version, it has this little jumper right here. You see it says CAN 120R. That needs to be on the board. All right. This one is important to have on this board because it's not built in. This allows you to select it. And what these do is to reduce chance of reflected signal, which can cause a lot of communication errors. So make sure that it's on the board there. On the sb2209, first, we don't need that anymore. That's the USB power. We don't need that anymore. But we do need the 120 resistor. And so you find these two big resistors there. You see them right next to it. It says 120R. It's this tiny, tiny little jumper right inside there that we need to jump. So this is what we use to complete the resistance. Basically, what we're doing when it comes to these little resistors that I'm pointing out right now, they are very important because what it does is it absorbs any reflection of unused data. So as data is being sent back and forth across the CAN bus, if you don't have these, it can actually cause a reflection. The signal comes to the end and then will be a lower strength, but still more signal coming back. And it can cause a lot of unwanted information or actually confuse the chips, and it'll cause a lot of communication errors. So if you don't get your UUID, or if you have communication errors a lot, check to see if you forgot to put the jumpers on. Like I said, on this board, it doesn't have it, but on the version 1.1, it does. And a lot of other boards also will have it. Also, there are some other things to keep in mind. These jumpers go onto the very first and the very last board. So right now, we're only going to have these two boards. So this is the first and last on the line. But for instance, this has the option of an added CAN bus. So these right here are for additional CAN buses. Like for instance, there's the cartographer. If you get the SIBOOR kit that I got, it comes with the eddy current cartographer sensor that which also communicates on CAN bus, and that's plugged into here. If you're using that one, that device has the resistor on it, and that device is actually the last in line. So you need to remove this one. You only have the jumpers on the very last and the very first, basically on both ends of the CAN bus line. If you can imagine, it's two rows, a high and a low line, and everything else is just attached. So the ends need to be capped off with 120 resistors. Okay? So that's something to really keep in mind. If this is your last board, you don't have any more CAN bus connections on it, then you can remove or leave this on. If you have something continuing on to another part, take that one off and make sure it's on the last one. The cartographer that came with this kit, for the SIBOOR kit, has it built in just like this, so you don't need to put jumpers anywhere. Just wanted to make sure you understand that. It is vital that you have a termination resistor on both ends. Okay? So once that's in there, your USB is out, USB power is off. Now we can plug in the CAN bus. Get that plugged in, lights on, we're good. Things technically should be communicating well now. Let's just put this off the side again, make sure you don't short anything. And let's get back over to Putty. Where is that? Back over to Putty. Okay, so now what we need to do is make firmware for this. But before we do that, we want to make sure that Katapult is actually working and communicating via CAN bus. So to do that, we can do it two ways. We can rerun that Klipper CAN bus query, or we can use Katapults. I like to use Katapults now because we're in it, and that makes sure that things are working right in Katapult also. So let's get back over. Let's see, where is that? Let's get back over here into Katapult's thing, because again, they've really well documented it. I recommend reading through all this anyways, even though you're seeing how to do it with this video, but it's good to kind of know what's going on. So what we're going to do right here is to query. We're using the flash tool, but if you notice, it just says flashtool.py and query. So that's a little bit, that is exactly what it is, but it's a little bit deceiving because you first need to come in. This one is assuming you're already in this one here. So we first need to come into the scripts folder. All right. And I will again put this down in the description. But what you can do is get back over, copy that, come back over to Putty, paste that in, and this is bringing us into the scripts directory. All right. So now when we're in the scripts directory, if you ls, you can see that there's a flash tool in there. And so that's what we're going to be using to do the query. And so to do that, let's see, you do need to do Python. I think it's 3 on this system. Python 3 and space. And then you want to do flash. And what is it? Flash tool.py. And then we want to ask it to inquiry, or to look at interfaces, which is the -i. And the interface is going to be CAN 0 is what we're looking for. Not O, it's CAN 0. And then space. And then with CAN 0, we want to -q, which means query. Query means to just see what's there. What's on CAN 0? We look, and now you see we have 2 UUIDs, which is perfect. That's what we want to see. because that means our Octopus board, which we've already saved, so you can cross-reference to make sure that's the right board, and the new SB2209 has been found. Both are communicating perfectly, and we're good. This is a perfect sign. This is hopefully what you have come to. If not, again, check your connections, make sure you've got wires set up right, your jumpers are in place and all that. If you only still see the one, you don't see the new one, it's more than likely that it's somewhere in the connections that you've made are not connected properly. So check your high and lower in the right spot, and yeah, make sure your jumpers are in place. So I think you got it. If you followed along so far, you've got this part here. So go ahead and copy that. Make sure you know, make a note of which one is which, because as you can see, it doesn't say who's who. It just gives you a number. One thing you can tell, obviously, right now is one says Klipper, and then the other one says Katapult. So that's an easy way to know right now who's who. But once we get Klipper installed on here, which is the next step, they will both say Klipper. So it's smart to copy this right now, which I just did there, to copy it out and put it onto a notepad somewhere. I'll do now. Okay. So now that we know that it is communicating via canbus, now we can flash Klipper to it. So now we need to go back to the Klipper directory. A lot of back and forth here. This is, I think, where a lot of people get confused with what's going on here. So what we do is cd enter, and that brings us again back to our home directory, right? So you can always check ls, this is the list, what's in there. And as you can see, you're in that directory where stuff is that your Klipper stuff. Now we want to get back into the Klipper folder. So cd Klipper. And then we're going to do a make again, the make menu config. Now we need to write Klipper firmware for the SB2209. I know it seems a little strange, didn't we just install? But all we did was the bootloader of Katapult, not the firmware for Klipper to know how to talk to things. So the make menu config and enter. As you can see, it has our previous stuff there, but we're not going to be using that. What we need to do is go ahead and go into our boards, because now we're writing it for the Raspberry Pi 2040. Again, that's our SB2209. Bootloader offset. This is important. You do want to put a bootloader offset because of the fact that it wrote a bootloader on the previous thing. So now we have an offset. We don't want to write over the bootloader that we just installed. All right. The next step is communication interface. CAN-bus. Not this one, not the USB. This is CAN-bus now. And again, like it was before, 4 and 5 and 1,000, 1 megabit. So all that's good there. And that's it. So we hit Q for quit and Y for yes. Okay, so now we come back out of here, we do make. But first, because we are in Klipper and we're making a new firmware, we have already made one, just to be sure, first run make clean. And this is to make sure that anything that was from that previous firmware that we made is erased, that we don't actually accidentally have something left over. Make clean first and enter, and then we're good. Sometimes, I'll do it one more time. Sometimes you'll see it do this, create symbolic link to out. That's good too. It doesn't matter if it does or not. Just make sure you do the make clean first. Now we do make. And this is going to write the new firmware. And I will be back. Okay, so now that that is made, we are ready to send the firmware over. And this is where it gets a little bit different than the original Klipper install. Because now we're not going to be doing anything about pushing buttons or anything on the system. We're going to be actually using Katapult to flash our firmware. So what we need to do, of course, since we're using Katapult, is get back into Katapult. So we want to cd out of here. Let's cd enter. And then we want to cd into Katapult. And then we want to go into the Katapult scripts. So cd scripts. Now we run the Python script to flash, and that is Python 3, and then the flashtool.py with a space, and then we do our I for interfaces on can0, and then another one. This is a new character of .f. This is going to be flashing a file, and that file we need to do, it's a little special because we need to add a tilde. That's a little squiggly line, and then /. Now when you type in the tilde, it won't show up right away until you hit the next character. So don't be alarmed if you don't see it pop up right away. Just do your tilde mark and then this. Actually, you know what? I will put this link. I'll put this line that we're going to type in here in the description, so you can just copy paste. All right, and then you have clipper, and then /out, is the out directory, and then /clipper.bin. That's the .bin file. So what we're now telling it to do is use this use Python to use this program, and this program is going to look at the can0 and then flash this file. So it's in this directory system, that file name. And then the next step, we need to tell it what UUID is. So /u, that's saying to use a UUID. And then that UUID is what we had previously got from our sb2209, not the Octopus one, the 2209 one. I got it off the side here, copy that in, and put that in. Okay? Once you do that, you hit enter, and it's going to do its thing. And as you can see, what it did is sent this boot jump command. So it in the firmware somehow has been able to automatically reboot or send itself into boot mode using this Katapult. And that's why I recommend doing it that way. If you noticed, we put in that command and it went through it. It reset itself. It put itself in. It found what it is. It found the file, everything that we gave it. And it even verified that it successfully flashed it. This SHA number is a way of it comparing the file that we told it, this file here, and comparing to what was on the board to see that they match. And that did. And so it was a success. And that's it. We are now successfully flashed. If we run that command again, but let's get rid of all this and then just do the -Q, we should have 2. Now we have 1 and 2, and both of them say Klipper. That's complete. You are technically done. If you know how to set up Klipper from here on out, you're done. You're ready to just go ahead and set up your profiles. I will show you a quick setup on that just to show you what's going on with that. But yeah, that is the hard part out of the way, really. that's everything set up there for Klipper to be working via canbus. But now let's go a little step further, and I will show you why also we need to keep these UUIDs and how to set those up. So let's get over to here, and we need to get into our main cell or your user interface here. So we have what was that IP address? 192.168.86. Oh, was it the 33? No, I can't remember. Yeah. Okay. Yeah. So we're in there. Now I'm getting an error right now because this specifically right now is set up with the what was it called? The SKR3, the mini E3. And so of course it's not going to be showing me that right. So right now what I'm going to do is, let's see, as you can see here, this is all set up for a different board. So we don't want that one. We want, let's see, how can I do this? Let's rename it. Get this one so it doesn't read. This isn't part of the setting up. This is I'm just telling it not to look at this anymore. So we want to do, let's do SKR mini, so I don't lose this information. Rename that. Now it no longer has a configuration. So we need to add a new configuration. So luckily for adding a new configuration, it's really easy. First, we need to create a file. And we're going to name it. Let's just do it the easy way. This is printer.cfg. Okay, so now we got a new printer configuration. Of course, it's blank. And then they set up really nicely. That's why I was showing you this generic board. So I'm not going to be setting up for a specific printer or anything like that. I'm just showing you how to get it to talk to your system. So basically, this is the generic configuration for your board. Now, if you're following something like the SIBOOR kit or any other kits, they normally have their own configurations set up ready to go. So you just drop it in. And the important part is you need to change this part here. And if they gave you a kit with a CAN bus setup, they probably already have a note about changing this. So we're not using serial, that's USB. What we're using is CAN bus. And I know that even though the Octopus board is plugged in via USB, because we set it up as a USB to CAN bridge, it is no longer using serial communication. It's being talked to as though it's a CAN bus system. Okay, so let's get copy on here. So we need to just copy the raw file and then get it pasted in to here. And then we go ahead and find that part that has this. So we don't need this anymore. This is not needed, but instead what we need to do, it says right here, CAN bus available. We use CAN bus underscore UUID. And then the 2 dots. And this is the Octopus setup. So that's the CAN bus UUID that we need. It's on the side here, paste that in. And now Klipper knows how to talk to my Octopus board. Okay, so that's it. We need to do, that's all we need to do there. And if I hit save and restart, it should pop up. We might get other errors because I don't have any temperature sensors. Yeah, see, it's in a shutdown mode because it's probably going to say the ADC. Yeah, I don't have temperature sensors put on right now. So here I can mitigate that by coming and putting a high or a very low temperature is what it would be on here since it's a NTC sensor. So let's see, minimum temperature is at 0 right now. Let's put it to minus 100. Don't do that. This is just so you don't see those errors. And we also have to do it for the heater bed. Minus 100. Okay, so now we save and restart. It should come back and be up and running. Maybe not. There we are. There you go. Now we have our MCUs connected. So this is the Octopus board. Now we need to get the sb2209 board. I'm going to create a new file. Oops, not upload. Create a new file and name this one just sb2209. And the important part is .cfg. This is letting you know it's a configuration file. Create. There we are. Now we come over to the example of that. This is Bigtreetech's just standard the SB2209 for the RP2040 chip that we're using. Again, same idea. You want to copy out, but we're not using serial. We're using CAN bus, which as you can see, they've done it, kind of set it up there. Copy out that raw file. Paste it into here. Go back up. We can get rid of this line. We don't need that because it's CAN bus that we're using. We can unhash this. That's a comment. So now it's no longer a comment. And of course, that's not our number. You need to get the number that you got from your SB2209. Stick that in there. And I'm going to do the same thing because of the fact that I don't have any temperature sensors on here, just so you can see that they're talking. Do not put minus 100. That's this minimum temperature at 0 is the absolute lowest you want to go. This is basically to tell it if anything is above or below these two numbers, then like if it's less than 0 or more than 250, then it's going to error out. That means that it's got thermal runaway. So you don't want to set minus 1000 or 100 because that means that there's a broken wire, which obviously I have nothing plugged in. I'm only doing this to show you that the board is connected. Okay, you don't want to put that because if you get a broken wire, the system will not know and it'll think that everything's fine. So anyways, put that there, save and restart. And now I should get no other errors. Do its thing. Let's see, no, but we did not get that board. Oh, I forgot one step. Of course, I put it into this file here, right? But printer.config is the master file. So until printer.config knows about this guy, it's not going to see it. So what we need to do is go back into printer.config. And then at the top here, we want to, not that symbol, this symbol. It's the brackets, and then include space sb2209.config CFG. So you want to include whatever you called it. It doesn't have to be SB2209. It can be whatever you want. If you just want to enable it stealth burner, or you want to name it George, as long as it's whatever one word and then .cfg, you're good. But it has to be included. So whatever that file is, it's going to drop all that information in this file. In the background, it's going to drop it into this file. So it's a good way to keep things clean. So now when we restart, let's see, what error am I getting now? Z offsets. Oh yeah, because I don't have a BL touch set up. Oh boy, let's get that uncommented or commented out. Let's see, where are you? Let's just comment out this stuff. This is a way to do multi-select. I'm holding Alt and you can drag. No, I'll just leave the ADXL. That's fine. Where's the BL touch? There it is. We don't have a BL touch plugged in, so let's hatch that out. If you hold Alt, you can drag, you get that plus, then you can drag and do multi-line selects. It makes it quicker to do that. Anyways, now, good that we get errors so you can see how I go about fixing errors. But now you can see, you got your MCU and then MCU EBB can. Now, if you notice the EBB can, the reason why that's there, that name is because that's what was default here. So you see it says MCU EBB can. So what this does is the MCU you're setting up as an MCU, which is what it is. It's the controller board. So even the sb2209 is its own little controller board. And then you give it a name. On your second controller boards, you can name it whatever you want here. But it's important, whatever you name it, why can't I select that? Whatever you name it there, if you notice, it pops up that all over the place, right? So whatever this name is how you tell it when you select pins, which pin board or which board the pin is on. So if you have nothing here, so a sensor pin, it says EBB can, because you're saying the sensor pin is this pin on this board. If you have nothing there, it's going to assume the generic board. So if this is missing, if it's like this, then it's going to assume that you're telling it that it's on the Octopus board, your main MCU. And that'll error out, of course, because the Octopus board doesn't use GPIO 28 like that. So that's why it says EBB can. You can, again, name this whatever you want, but if you do change this name here, then you need to change it everywhere else. All of these EBB cans need to be changed to whatever is added here. So it's easy, it's just to leave it the way it is since it's already made for you. But you can customize if you want, of course. So that's that. Now you can see we have both of them, both boards are talking, they're awake, everything's good. Both on the current firmware or whatever the current firmware was at the time of making this. As you can see here, I have updates, but it is on all matching firmware and you're good to go. The rest is all up to you. It's all about doing your configurations. I got lots of different videos of how to set these different things up, like the LIS2DW if you want to use something else like that. If you're using a stealth burner, the nice thing is the sb2209 has an accelerometer built into it, and that was already set up for you here. So you got your ADXL, here's your accelerometer, your resonance tester, everything's all set up ready to go. You just have to start, do your input shaper if you want to do that. So really nice, everything's built in for you. If you're using this on a bed slinger, then you'll have to set up one other one, of course, for measuring your bed resonance. But yeah, that's how you got it going. So hopefully this got you to the point where you can do the rest and you can learn more about doing setups. And like I said, I have other videos going over what the printer.config video is, or folder is, how to set that up, what's important about it, and all the other good stuff. So check out if you're interested in that type of stuff. And hopefully, again, like I said, this got you going. I want to give a big thank you to all of you who have stuck it out. I know my videos are long, but I want to do it more as an educational video so you can really see what's going on and really truly learn. So in the future, you're able to do your own type of configurations and troubleshooting. This should help you out and now understand how the system works so you can troubleshoot. That's why my videos are long-winded and not direct to the point, just copy paste. Okay? Hopefully you like that. Thank you again for watching. Big thank you to PCBWAY for sponsoring my video. Give them a check out. If you're looking at anything that's not just PCBs, you can do 3D printing if you want to get your Voron machine stuff printed in some high-end, really expensive PEEK material, for instance. You can do that as super strong materials. Not really recommended, but you can do that type of stuff. You can have all your parts made by them. If you want to do some custom CNC, anything else that you want to do, they got it all. 3D printing, CNC, sheet metal bending, of course, PCBs. Lots of cool stuff and great people to deal with. So definitely worth a shot if you're looking at doing any type of fun make stuff like that. But yeah, again, if you have any questions, leave them down in the comments. I will love seeing any type of input you have, any questions, anything that seemed confusing, or if you feel like I've missed something, you want to leave that input, all of it's welcomed. I love reading the comments. Thank you to everybody that does engage. It's really helpful, keeps me going, and also gives me good insight of what you guys want to see. So leave those comments. I like it. I do read all of them. I try to respond to every single one. So anyways, again, yep, thank you. And I'm going to cut this video short before I start rambling. Talk to you guys later. And until next time, get out there and go make something. Have a good one.